function transformation of logarithmic function log of x. So I am going to use log of x as my parent function, and then I will do function transformation, shift the log function up and down, left and right, and then create reflection. Alright, so starting from the first graph, before we start, I have to remind you that function transformation is not that easy at your first glance. Therefore, when you study function transformation, I highly recommend you to open the app called Decimal, DESMOS, graph the function, graph the transformation, put everything on the same screen, and then change the numbers around to see how the function shift up and down, left and right in the same window. Great, so let's start on the first graph. So the first graph, my parent function is log of x, that is the red curve. And then what happened when you add 1.5 to it? So when you add 1.5 to it, that shift the log of x 1.5 units up. So the point that I want to see is for log of x, there is an x-intercept at 1, 0. So when you shift the function 1.5 units up, instead of having y equals to 0, it will jump to 1.5. So that is 1.5 units up. When you add 1.5 to log of x, that shift the curve 1.5 units up. So from the y-intercept, sorry, I keep saying it wrong. The x-intercept goes from 1, 0 to 1, 1.5. And then I should also say that since this is no longer on the x-axis, 1, 1.5 is not an x-intercept. But what I'm trying to express is you have to grab a point and then to see how that point from the parent function shift up. So in this example, I use 1, 0 and 1, 1.5. How do I get this point? On the decimal, on the screen where you input the function, there is a gear icon in the upper right hand corner. Click the gear icon, you will see that there is a table icon. Click the table icon, and then they will let you input the x value. So just put the x value, they will calculate the corresponding y value for you. And then for this order pair, this point, they will just put the point on the graph. So and then you can move your cursor, tap at the point, and then they will tell you exactly what the x and y coordinates are. All right, and then let's take a look at the green curve. What happened when I subtract 2 from the log of x? So when you subtract 2, that shift the log of x 2 units down. So it was at 1, 0, so shift 2 units down. So now it is at 1, -2. 0 minus 2 is equals to -2. Now, my suggestion to you is don't stick with what I gave you. For the purple function, don't stick with 1.5, try something else. Try log of x plus 7, plus 6, plus 2, plus 4, plus 4.5, plus 5.6, so on and so forth. See how the log shift up when you change the number. And then also for the green function, don't just stick with the -2, try something else. Try -3, -5, -7, because you have all the times you want. You have the decimal app right in front of you. Everything is super convenient and super easy to learn if you can do all these works by yourself. Now, moving on to the graph on the right, I use the same parent function, log of x, right over here. So what happened when I still stick with the 1.5 and the -2. So this time what happened if I put the 1.5 and the -2 right next to x? So what happened? When you add 1.5 to the x, that shift the function 1.5 units to the left. So 1.5 units to the left. I should put it right here, 1.5 units, or I should match the color for you. So this is 1.5 units left. 1.5 units left. From where to where? From 1, 0 to -0.5, 0. How do I get the -0.5? Easy. Take 1, subtract 1.5 to get -0.5. So here is the transformation from here, 1.5 units to there. And then what about the other one? The other one is log x minus 2. You put a minus 2 right next to x. That shift the parent function 2 units right from 1 to 3. Okay, so x is equals to 3. So let's take a look. When x is equals to 3, 3 minus 2, 3 minus 2, that is log of 1. Log of 1 is equals to 0 because 10 to the 0 power is equals to 1. All right, so that is how you shift the function up and down and left and right. So before we move on to the reflection, let's do a quick summary. If you put a number outside of the parenthesis, like right here and then right there, that shift the function up and down. Plus is shift the function up, minus is shift the function down. Also, when you put a number inside the parenthesis right next to x, plus is to the left, minus is to the right. Okay, so that is the up and down, left and right. How about reflection? How about reflection? So for the next graph, I have the red curve, a green curve, and a purple curve. So for the red curve, this time I didn't use log of x, I used log of negative x. So when you put a negative right next to x, what happened? When you put a negative right next to x, you create a reflection in the y-axis. A reflection in the y-axis. Now, what reflection? It was like that. So once you create a reflection, what does that look like? Do you see that once you create a reflection, it doesn't go like this. It won't just reflect like that. Actually, the point, the x-axis, just jump from 1, 0 to negative 1, 0. So the entire point just jump. Like how? It was right here, and then it just jumped like that, reflection in the y-axis. It was at 1, 0. Now it is at negative 1, 0. So from 1, 0, do you see that? From 1, 0 to negative 1, 0. This is a reflection in the y-axis. Now, after the reflection, what happened when you subtract 2? When you subtract 2. So when you subtract 2, and then you just go from 1, 0 to 3, 0. From 1, 0. So if you do not consider the minus and the minus 2, then you are back to the log of x, which is the parent function. And then for log of x, we have an x-intercept at 1, 0. That's why I put it right here. So once you do a minus 2, once you put a minus 2, that shift the log of x 2 units to the right to 3, 0. And then you put a negative in front of the x, that creates a reflection. So this is a jump now from 3, 0 to negative 3, 0. So from this point, 3, 0, and then you jump right over here. We create a reflection to negative 3, 0. And then that is for the green curve. And then what about the purple curve? From the purple curve, we have log of minus x plus 1.5. Let's do it step by step. So at the beginning, we have log of x, and then we have 1, 0. We have 1, 0. That is the parent function. And then once you add 1.5, what happened? When you add 1.5, you shift the 1, 0, 1.5 units to the left, to negative 0.5, 0, which is right over here, negative 0.5, 0. Once you create a reflection, it will just jump. How? So once you create a reflection, negative 0.5 was right here, right? Once you create a reflection, it will just jump over to the other side. So from negative 5 to past, from negative 0.5 to positive 0.5. Once again, for function transformation, you do have to change the numbers around. So I suggest you to try the following. Instead of using negative 2, try negative 3, negative 4, negative 5, and then this one try plus 2, plus 3, plus 4, plus 5 to see how the transformation is done. Don't just take whatever I gave you and then think you can do this on your homework. Right? So that is the end of this video. If you like the way I show you function transformation, give my video a thumbs up, give my channel a subscribe. I truly appreciate your help and support to the channel. I will meet you all in the next lesson. Signing out.